Hello, everyone. This is Pavel Pavlak speaking. Welcome on our ONAP Security Subcommittee weekly meeting. And special welcome to Rahul, who is our special guest star today and giving us some update on the new interesting technologies and solutions like eBPF, LSM, KubeArmor, and runtime zero trust via granular access control policy development and enforcement. So I guess I could give you the presenter role, Rahul, right? Would you like to have?
Yeah.
All right, let me just click. And stop sharing, so sure.
Yeah, I think I have the control. Can I just go ahead and share my screen? I have done that. Okay, folks, thank you for having me. What I'm going to do is maybe spend 15, 30 minutes. I'm going to cut all the other things, directly come to the point. When I last discussed with Mudasar, and I saw some of the documents present that were prepared by the ONAP Security Committee. One of the things that I noticed is that there was threat modeling done. There was an external assessment done of the ONAP solution. I saw the Casablanca report, and I saw some of the service mesh, the detailed documentation, the detailed service mesh architecture, and the implementation, the flow level details as well. One thing that I wanted to bring to the table here is what is the impact of eBPF in general. And I'm going to focus primarily from the policy enforcement perspective, like eBPF, BPF, LSM, and the likes. Like, how do they change the landscape for security? That's what I'm going to talk about. A brief background about myself. I've been into networking and transport optimization space, primarily for Linux kernel optimization for networking and transport domains. For past 25 years now, work primarily for data center. Data center was my topic of interest, and we used eBPF there primarily for packet steering. One of the last topics that I worked with eBPF in my past organization was to steer quick traffic so that you can minimize. So quick traffic has a lot of different dimensions, characteristics, and you need to steer the traffic to the right core, and eBPF was used there. Since then, eBPF has changed a lot. That was in 2019. Since then, eBPF has changed a lot, and some of the primitives that are now upstreamed into the Linux kernel and are ready, and most of the cloud providers support it, and some of those primitives are currently underutilized, is what I feel. We have, of course, started utilizing some of those frameworks, and how does it provide us with some of the differentiation is what I'm going to talk about. When anyone talks about eBPF, most of the times, folks are talking about eBPF from observability and monitoring perspective, and that's basically making use of certain hook points in the kernel space. So how much I'm going to assume here that folks are familiar with eBPF, or rather, let me give 1 minute overview about eBPF, how eBPF changes fundamental security premise of the Linux kernel. With eBPF, you can now insert programmable code inside Linux kernel such that you can steer the packets, you can observe the behavior at the system call level, or using k-probes, k-rate probes, and trace points. There are multiple hook points. So eBPF has 2 or 3 primary aspects. One is the virtual machine. The other is other set of hook points in the Linux kernel. Where is the eBPF bytecode that can be inserted at? And the third is the BPF helper, which usually doesn't get talked much about, but that's also an important point because BPF helper functions are available for a given hook point only. So the TC ingress, egress hook points and XDP hook points, the BPF helper functions would be drastically different. So you have to understand. So it's not, that is why it gets complicated there. That's why it's not a general purpose programming language or general purpose. So unless and until someone has a flair for kernel, they won't be able to, they might not be able to appreciate the differences between all these aspects. So that's why it becomes sort of complex. Things are getting changed though. Like a lot of engines are using eBPF, and under the hood they are providing. Under the hood they're making use of eBPF, and above the hood they're making use of all sorts of improvised, user space languages such as YAML and things like that to actually specify the policies and rules. So when it comes to eBPF for policy enforcement, most of the times when people talk about policy enforcement, they used to talk about network policy enforcement, like how do you do packet steering. And obviously the three controls that are available: allow the packet, drop the packet, or reject the packet, or redirect the packet to a specific interface. These are the three primitives that were available. And one of the primary goal of eBPF had been to use to do network control for all these aspects. Like the packet control part was the most important aspect, because of which eBPF got introduced. With the advent of newer kernels, like I've mentioned here, BPF LSM for system policy enforcement, and this is an aspect which is hardly talked about in the open source community even. BPF LSM changes things a lot, in my opinion, because traditionally, if you look at traditional LSMs, when I say LSMs are Linux security modules. You think AppArmor, SE Linux, they have been in the Linux kernel for past 20 years. BPF LSM is a new LSM which allows you to inject eBPF bytecode at the LSM hooks. And at the LSM hooks, you have the ability to do policy and you have the ability to do controls or the enforcement. What I mean by that is you can say deny access to a particular object, and that object could be a network socket, it could be a file object, it could be a process execution task, things like that. So you can actually do some controls for the first time outside of network packet control. Now you have the ability to do some sort of policy control for system primitives which were not available before. Now, when we started AccuKnox, I'm one of the co-founders of AccuKnox, and we basically started working on runtime security because that's where we found the major gap. So we focus primarily on workload hardening. How do you ensure that when someone reaches the pod, and if there is a vulnerability available inside the container image, then that vulnerability, even if someone is able to exploit that vulnerability, they should not be able to do much damage. The blast radius should be contained and all that. That's where the problem statement we focused upon, which means that we ensure that the least within the pod, the least amount of execution happens. And for that, we primarily targeted LSMs as the option. There were a lot of other options, but all those options had different problems. Like, one of the popular vendor is making use of is changing the container runtime interface and adding its own shim layer in between the container runtime interface. We cannot take that approach because it is too intrusive. We can't expect users to change the container runtime interfaces. In some other cases, a dynamic library is inserted into the application workload, and that's a popular model actually. That is also a big no, because your FIFS compliance, a lot of compliance related aspects go for a toss if you do that kind of policy enforcement. The third is changing glibc and inserting your own libc. All these options are possible. I can enumerate like 20 different primitives, and we have done a case-by-case study of pros and cons of each of these primitives. Eventually, we realized LSMs is the best way, which doesn't support, which doesn't have problems from the, there's something called a stock tower, right? Time to check versus time to use problem. It doesn't suffer from those kind of problems. So we eventually ended up making sure that, we want to add support for workload hardening using LSMs. Now, when we started, that was in 2020, the primary LSMs that were available were AppArmor and SE Linux, and they were not available consistently across all the cloud platforms. GKE, which had container optimized OS, supported AppArmor. EKS supported SE Linux only. BPF LSM was just upstream, like it was upstreamed in kernel version 5.8. 1 year down the line, so when we started, BPF LSM support was available on less than 5% of systems. 1 year down the line, in 2020, end of 2021, we saw that the support increased to maybe 50% of platforms, but it was still not good enough. Today, we are at a stage where 95% of cloud providers, which includes Azure, AWS, GKE, OpenShift, IBM Cloud Services, VMware Tanzu, all of these support BPF LSM out of the box. OpenShift, of course, I think I mentioned about OpenShift. All of these support BPF LSM out of the box. Now, this has huge implications because just the way eBPF sort of deprecated IP tables, I feel AppArmor and SE Linux are going to be deprecated because of BPF LSM. And the biggest advantage with BPF LSM is that you don't have to work within the constraints of a semantic language, which AppArmor and SE Linux tells you. You have to work within a type enforcement language that there is something called as common intermediate language provided by SE Linux. You have to work within the constraints of those language. With BPF LSM, a user can specify an intent. That intent can be converted into BPF bytecode, and that bytecode can then be inserted in LSM hooks. If you think about it, it's an extremely powerful primitive. And the advantage is that you have less of other issues. Like with eBPF, you don't have issues about your kernel going into crash because eBPF by itself is extremely constrained. So which means that you won't be able to use certain functions, or so you won't be able to target certain memory space out of its own constraint. But within those constraints, you are still able to target most of the use cases. That's where our primary journey began. So we decided this is a primitive which is ripe for enforcement, which is the right primitive for enforcement and ripe for adoption. And that's where KubeArmor started. That's the policy engine that AccuKnox we developed. It's part of CNCF project today. So I'm going to go next. So here you see a system call. There is an eBPF bytecode that can be inserted here, and there is also VFS, like the virtual file system module. You can insert eBPF bytecode here. You can insert eBPF bytecode here. This is essentially XDP, or this is essentially XDP module. Even for the storage layer, you have eBPF bytecode that you can use to steer the control. I want to talk about uBPF as well, and I'm not sure if uBPF is not often talked about. It's an important thing because eBPF is a kernel space technology, and by definition, Linux kernel is a GPL kernel, which means that any extensions that you write in eBPF have to be in GPL as well. So most of the eBPF bytecode that is written today, like 90% of it is GPL, and other 10% of it does some trivial stuff, which it cannot handle without the other BPF helper functions, which are GPL anyways. So the biggest problem with eBPF is that it's GPL. Again, I don't know whether it is a big problem because the user space code need not be GPL. Linux kernel says that anything between the system call boundary, you can on the one side of the system call boundary, you can have any license. On the other side of system call boundary, you on the kernel side, you have to mandatorily have everything in GPL model. That's a constraint that Linux kernel enforces. How uBPF changes it? uBPF is a user space implementation of BPF, which means as a equipment vendor or as a vendor who is writing an XApp, let's say for example, you can then use uBPF and allow programmability of your own software component module. Eventually, the way I see it, this will get standardized. In fact, IETF is now standardizing how eBPF should be consumed, some of the instruction set and all those things. With that, what will happen is eventually we will have XApps adhering to certain uBPF standards, and then external vendors who are providing add-on services on these XApps would be able to use these hook points and expand the scope of what XApps can do. Again, this is just an hypothesis today. I know of one vendor who is trying to use uBPF for their RAN modules, primarily for this purpose, but I've not heard of many to be used. Again, feel free to interject me at any point in time.
So Rahul, a
Yeah,
quick
yeah,
question on that topic.
yes.
Would that be also used where you may not have access to kernel itself when you're buying services like in Mac or commercial cloud, that you could use uBPF to have your application enforce policy or tune the network?
Absolutely, great point. Yeah. So that I should have mentioned that. Yeah, uBPF has that added advantage that it need not necessarily be Linux kernel now. You can make a use of it on Mac and Windows, but I believe the components that we are talking mostly are on Linux. But another important point is that you have a lot of user space networking done on DPDK and fast path transport, right?
Mm-hmm.
Those could be bought under the purview of uBPF, and you will have a same consistent BPF bytecode that can be used either in user space with DPDK or in kernel space. And you'll get the same hook points or similar hook points, and then you'll be able to do all the statistics, observability, monitoring, and all those kind of cool stuff. Yeah. But yeah, that's a good point. Like, with uBPF, you get portability. Today, it supports Mac as well as Windows and Linux.
All right, thank you.
Thank you.
Rahul,
Yeah,
this is Amy Swariko. Could you go back to the other slide for a sec?
Yeah.
Thanks. So when you're doing enforcement with eBPF or the uBPF, this seems to be, what are the use cases? Because it looks like what I have here is that I'm making sure that, say, something running in a pod is you block it from hitting storage that it shouldn't be hitting. So I'm kind of I'm guessing, is that the use case? I'm trying to understand the distinction between, say, the fine-grained access control that I would do on users within an application versus more operating system level, where I'm making sure that if I have a process running, sorry, I'm going to go back to my old roots. If I have a process running, it has a process ID, it is only allowed to access certain things. And and the eBPF is going to block that process ID from getting out. So is it both use cases? Is it one of them?
Yeah, I would suggest, since you brought up that topic, it might be important to talk about some of those use cases. Yes, it's more closer to the systems than to the user. For example, you can do process whitelisting, process allow listing. You can say only these set of processes are allowed to be executed within a workload. And typically, when you ship a container image, the base layers contains a lot of existing. Even if you take Alpine by default ships with APK, the package management tools, and these tools should never be used in the production environment, but they are out there. There are attackers such as the two attackers I know about, Hildegard and
so
Black
this
Team.
is an easier. So this is, yeah. So
Sorry,
if I could interrupt you for a second. So I think that for that level, the eBPF is definitely allowing me perhaps a simpler way of hardening my OS layer.
Right.
Which is really nice.
Yeah. That's exactly what it is. So let's assume that we have service mesh in place, and let's say there exists a vulnerability. The attacker is going to come on the existing standard ports anyways, because there exists a vulnerability, there exists a 0-day. Let's say, for example, it's a log4j attack, right? So the attacker comes in, the attacker tries to do a remote command execution. Typically, the attacker will push the binaries into /tmp folder because that is the writable folder which is available for the most applications. So that's a popular model. Once the attacker pushes the binary to /tmp, then the attacker will try to check for credentials. It could be service account tokens in the context of Kubernetes. If you take any Kubernetes attack, almost every attacker in second or third step, once the injection is done, once the initial access is done, they go for lateral movement and they try to search for the service account token files. Again, the MITRE has done a terrific job about documenting all of these things. So service account token is then identified. The attacker wants to send beaconing signals to their command and control servers. So the remote code, the command that is injected need access to network primitives. All of these things essentially can be disbarred by eBPF. eBPF can say that, there are two models. Like one is you learn the application behaviors and see that these are the only processes that needs to be allowed execution within the target environment. And within these processes, only these processes need access to the network primitives. And only these processes need access to certain sensitive data points, including sensitive data points. Like, you have volume mount points within the pod. Today, the fundamental problem with Kubernetes as a design is that within the pod, almost everything has unrestricted access to everything else. You have multiple containers. Yeah, that's the fundamental problem that is tackled by eBPF today. Yeah.
Okay, so if I can read that back to you, is that what eBPF is doing for me is it's giving me potentially a simpler way of implementing least privilege at the kernel layer. And so what I can do is, for example, your temp file. I can make sure that I have set things up so the temp doesn't have access. I can back to the Kubernetes. That's one example. A second example is that with Kubernetes, which again has far too much unrestricted access, I can use the eBPF, with the LSMs. I can use that to set up policy that restricts the Kubernetes access to really only what that particular Kubernetes module needs. For example, when I get and by the way, I'm from AT&T, so I'm going to speak in terms of being an operator. When I get a VNF, when I get a CNF from a vendor, 5G, something for my 5G core, I'm going to get, and it's going to be containerized. Just that's reality today. Yeah. I'm going to pull that, I'm going to get that container, but that container, and they're probably going to send me the Kubernetes stack as well. Again, reality. I should be able to get that within it. They should provide me with an LSM that says exactly the minimal amount of access that they need, and I can configure the VM that's running that the Kubernetes is going to run on to only allow that access. And therefore, what I've done is I've solved one of the problems that people worry about with Kubernetes, which is the extensive access that Kubernetes has to the container. And you're saying, oh, well, just trust all the pods are cool. And, I'm a security person, so yeah, all the pods are not really necessarily cool.
Yeah.
So is that a model that could be supported?
Yes. That's the model that is the best model to actually use, where the vendors themselves.
So the vendor has to declare exactly what access they need. And I have the ability to either they send me the LSM and I can check it, or they tell me exactly the access. I set up that LSM myself. And if the pod doesn't work, I call up the vendor and say, I think you forgot something.
Right. But
I think that your manifest is wrong, essentially.
Yeah. That's the model that is in an ideal world would be the right model to follow. And that's the right model. But what is happening today is that since LSMs are still not a popular technology, right? For certain reasons.
I know they're not. One of the women who works for me is very excited about LSMs at eBPF. So she's on the West Coast. So this would have been very early even for her. But I'll probably have her listen to the recording.
Yeah. So one thing that is happening today is that rather than vendors supplying the actual the allowed list, denial list, and all those things, there are ways to actually auto detect. So if you have a stage environment, if you have dev environment where it is going to get deployed first, there you identify what are the possible options. So there is another engine that can sit on top of the telemetry and observe the application behavior, and based on that behavior, it can auto generate the schema that is required for LSM. And
so is that part of KubeArmor?
Yes. Yeah. So
okay,
KubeArmor does
that's extremely cool. Thank you.
Yeah.
Have a use case for that. So
Yeah, that's basically the problem solving. So with KubeArmor, what you get is both the things, both the alerts and telemetry, as well as the ability to do policy enforcement. And one of the things that I want to again highlight here is that there are other engines that can do policy enforcement, but what they do is they do a detect and respond kind of model. Detect and respond kind of model in the sense that there are rules which can identify malicious intent. And the policy engine can then take a remedial action in the form of suspending all the processes within the container, or deleting the pod itself, or quarantining the node. There are so many actions.
Or at least notifying somebody, because
Or at least
I'm
notifying.
probably not going to do that on my 5G network and potentially have an outage. Correct.
So but the fundamental problem there is, if you have an attacker like ransomware attacker, by the time you take a remedial action, the file system asset would have been already encrypted, or they might have deleted the content.
Absolutely. But the problem, you need to understand from an operator standpoint that it's got to be really dire to do something that could take out cell service for an entire region.
Yeah.
And as people who operate FirstNet, first responder, probably can't do that. We probably have to, there has to be some form of detection, but so you have to balance the two. But this is really interesting. So I'm glad to hear about it for the second or third time now.
Fabulous. Okay, I'm going to go back to the service mesh models, and then I'm pretty sure most of the folks here are aware of all the service mesh models. Sidecar model is the most popular one, and I feel today, from security point of view, that is the model which makes more sense than anything else. Even the ambient mesh model is getting more traction these days because of the performance improvements and things like that. Sidecar model has fundamentally some aspects which allows it to do security isolation. The isolation properties of a sidecar model are much more better than an ambient mesh model. What my intention to bring to this team was to explain what is it that eBPF can change with service mesh, and what is it that is happening with service mesh with eBPF. And eBPF does not fundamentally change how service mesh operates today. The primary way in which eBPF is being made use of in the context of service mesh is for packet redirection efficiencies. Rather than using IP tables rules, you have eBPF for packet redirections. So that's all great. You remove dependencies on IP tables, you scale packet redirection efficiencies at much larger scale. You have granular visibility. Like, this is a connection that came inside, and this connection eventually ended up at this particular container, and this particular process is the one which handled this particular connection. You can get that kind of visibility using a combination of service mesh and eBPF. Having said that, I don't think any engine has done that, and correct me if I'm wrong here, any engine has done that as of now. I know Cilium folks are working heavily towards that, but using an external connection that is coming inside, ending up at a particular container, and then handled by a particular process, that level of visibility is still not available. But it is possible to get with eBPF and service mesh when put together. The other is also sorry.
Just quick, sorry about that. Maybe I'm gonna wait. In ONAP, we apply the service mesh sidecar based the security between the application to application ONAP component protect. So I think we're gonna continue in that direction for a while, and then but for network function onboarding, and we from vendor and others, we are interested in KubeArmor because unlike an ONAP component, network function can be thousands. We don't want to put sidecar everywhere. So that was kind of, we tried to direction, maybe ONAP component. Probably in the future, we can combine sidecar and then this KubeArmor some way. But for now, we stick to service car based service mesh and ingress, and then KubeArmor based authentication authorization. But the NF we allowed to use KubeArmor like you proposed to Nephew. That's my understanding.
Yeah.
Okay.
The same has been here. We have, it's a very early stage proposal that we have made to Nefio. The security committee has, has just been formed. So hopefully you'll see some movement there in the coming few weeks.
Yeah, I'll be there anyway. So anyway, just this, I'm just sharing the ONAP what current situation. So
Right.
we already set up service mesh, and we are looking for this new KubeArmors for network function onboarding. Okay.
Right. Absolutely.
Thank you.
Thank you. Direct server return. This is another piece which essentially was introduced by Cilium folks. The primary intention with direct server return was to reduce the communication legs when the traffic is hitting multiple proxies on the same node. So you can reduce the communication legs for response traffic and things like that. Again, I'm not a big fan of this kind of architectures because having symmetry is again, the performance benefits are surely there. One of the primary reasons why all these things are getting discussed in the service mesh community is because the performance impact of service mesh on the overall traffic latencies and is extremely high. What I hear is 20 to 30% impact. If some of these technologies can certainly bring down that impact to maybe less than 10%. But again, there are security implications. There are architectural implications that one has to keep in mind when anyone is doing any of these things, especially the direct server return. Like, you can have communication legs that are removed altogether, but it might have an implication on the overall architecture, how you thinking about it. So these are the three things that eBPF
Rahul,
usually,
Rahul, you mentioned something that introduces as much as a 20% I think a 20% performance hit. What was that? I somehow missed.
So when you introduce sidecar-based models, especially you introduce a proxy for HTTPS traffic, you are now basically encrypting or decrypting the packets within that sidecar to figure out the APIs, and that performance impact of doing that stuff in sidecar is not trivial.
So how does that compare with the TLS endpoint being someplace else? I mean, aren't you going to have the same hit, or does the Kubernetes or when I'm running as a sidecar, does it not make use of a hardware accelerator?
No. Let's assume that the hardware accelerators are in place.
Okay.
Like my assumption is that hardware accelerators are in place, but just the sheer the amount of traffic that has to be handled. What happens is, in the context of Kubernetes environment, now you have all of these pods. You can have 110 pods on a single node. That's the maximum limit that is set by most of the cloud providers out there. If you have one sidecar on 50% of those pods, which means 50 sidecars, it has serious resource implications. And those are the resource implications, both from the CPU perspective as well as from RAM memory perspective. You're decrypting most of the traffic. But yes, if you need to decrypt the traffic outside of your application, then you will hit that performance problem anyways.
That's what I was thinking. If I have to do encryption, I have to do encryption. So I'm running the same algorithm. Complexity theory would tell me that I'm going to have the same hit on my compute no matter where I do it.
Yeah.
So I think that to me is an argument about somebody whining at me, why do I have to encrypt? It has nothing to do with where I put that I put a sidecar to do it, right? Does the sidecar introduce additional latency over some other model for the encryption? Because let's just say that the encryption is mandatory.
Correct. No, encryption is mandatory, and the sidecar is going to introduce that encryption overhead, but it's not an overhead, is what you're trying to tell me. It is something that needs to be done, right? You have to achieve encryption.
It's part of the application performance.
Right.
So I think that's as a security person, since I've been dealing with people whining at me about encryption for over 20 years now, and the horrible overhead and why am I making them do this? I think as security people, we need to get away from that. If your workload has a mandatory encryption requirement to ensure confidentiality, then sorry, it doesn't matter whether it's a sidecar, it doesn't matter if it's a load balancer in front of it. I have that requirement, I need that compute. So that's why I was questioning, is it adding latency over what would happen if, say, I put it on a load balancer? Or, I mean, I'm that old that I remember doing that.
I think the only latency that we are talking about is the latency that is induced because of multiple proxies that might come into picture on the same node. So you have pod 1 talking to pod 2 on the same node, and you have multiple proxies that are coming in the picture. So that there are some optimizations possible, and that's what essentially eBPF would possibly allow you to do.
Okay, thank you.
Yeah. The other part is, can eBPF help in decoding HTTPS? That's again a frequently asked question, especially for me, because people say that, with eBPF, you have visibility into the packet payload, but you don't really have visibility into what that payload, you can't really decrypt that payload with eBPF, right? You need the keys, you need all of the other things. One of the models that has been now becoming more popular is attaching uprobes. So with it is possible, just like K-probes, I talked about K-probes, which are essentially kernel probes. You can have user space probes that can be attached in user space application without changing the application itself. And then you can basically hook into certain APIs such as SSL write and SSL read. I know, as a security vendor, we have tried ourselves to keep away from this as of now, but I know that this is a tech that is being used today for decrypting HTTPS traffic transparently, to get visibility into what API calls have been made between the two microservices. This is one of the popular technique that has been made use of, where you hook into OpenSSL.so, and then you get the visibility information of this. So you can insert a BPF bytecode at SSL write, and then you transfer the code, the payload to your user space processing logic, and then decode the packet, parse the packet there. You don't need any keys here. But this is risky because essentially you're opening up the gates for accessing user traffic blindly for certain application, and tomorrow the attacker might as well leverage this aspect. So in my opinion, this is a bigger problem. You are actually opening the gates to certain things which was not possible before. So yeah, but this is a model that is getting heavily used or professed in the outer world. I would like an opinion here. If someone has an opinion.
I have an extremely strong opinion on this one. You should ensure confidentiality from endpoint to endpoint. You should not, in my opinion, there are very few cases where you really ought to be putting your own man in the middle in this, because the thing that's in the middle, the ability to intercept that, the sender and receiver thought that they had a confidential channel between them, and you stuck something in the middle. And I've been arguing against this with people who want to have firewalls that decrypt traffic so that they could do payload inspection at the firewall. And I've been arguing that it increases your attack surface. And I've been arguing that for years.
That actually, yeah, I'm completely in sync with what you said. I'm not a big fan of this either. So yeah. At any point in time, if you can access the user space traffic or the decrypted traffic without keys, there is a problem, right? Without getting the keys in a proper way.
And from a zero trust perspective, it seems to violate the first principle, which is the first, or second principle. Well, the first principle is basically you can ensure confidentiality. So you've encrypted all of your traffic, because there's no safe space in the transport. So,
Yeah. I'm going to just note it down. Yeah, because putting it in the context of zero trust makes more sense. You basically are violating the principles of zero trust. So yeah.
But I'm kind of
So-
interested in other people's opinion on the call. Byung, Mudasar, Pavel. I think that others, it's because I seem to be dominating.
Well, so in terms of where things can be read, right? If the secure calls were intended between client and server application, the other stack that's supporting that call should not be able to read it, right? So as you guys were earlier talking about, man in the middle, this is the capability you're generating, and that capability will be used. So most adversaries live off the land, right? They don't come with specialized tools. They use the tools that your organization provided, and they capitalize on it. So this would be one of those things where some use cases may require, and that could be, forensic use case or something else. But if you're going to deploy, for example, in commercial cloud or Mac, where you may have limited access to the full stack, and having this kind of work, just leaving some windows that locks can be broken.
Yep, agree. Man in the middle, so okay.
Yeah, I mean, this is purely for forensics purpose, Minister. So you can't really stop traffic from flowing here, but it gives visibility into what the traffic is without having to use the keys.
So I think the real use case, Amy, you're asking, what could be the use case? If you're in a staging, integration, or solution testing environment, you can have special implementation to do a full discovery to make sure you're satisfied with all the flows and your policy works as designed. And then you take this out when you deliver it in a production environment or runtime environment.
Exactly. And you're doing your testing with synthetic data. You're not using real data. If it's compromised, big deal.
Yeah.
I mean, this isn't, sure, you could do that, but if it's really important that you know all your transactions, then you make sure that your application space is logging the API calls. Now, you don't have to log, you shouldn't log all the data because, you could have sensitive data that you don't want winding up in a log file, but minimally the name of the API, the URI of the API. There's all different places you can enforce security. It doesn't all have to happen at what is essentially a firewall rule.
Mm-hmm. So this would be, it's more of understanding the architecture, how well it's working. In most cases, you'll be using uBPF to restrict access in actual runtime, because there are use cases when you're going to deploy your workloads. There will be some management workloads that might need to go on the same node or they may end up on the same node without you knowing if it's a commercial cloud. And that will require that you use uBPF and eBPF to segregate actual processing down to the system calls. And there has been talk, at least in a highly sensitive workload deployments, to even have in-memory decryption process and send it back, so they can reduce any chance in the full stack, starting from application down to the system call or interrupt call, that things don't get open up, because there are chances where you may have co-resident applications. They get processed in the same environment once it goes to the host OS. So there have been techniques put in to segregate those, or can sort of create microcompute environments just set up for that particular application, and its contents or its processes are not visible to co-resident applications.
Yeah. So in the interest of time, right? Like we have since just 15 more minutes. I'm going to I have just 3 more slides to be presented. 2 more interesting points to be made. One is uBPF or my user space BPF, right? Like the primary reason why it is needed is to handle the kernel bypass problem and the kernel space license issue, like I've already talked about. But one another use case that has been satisfied with uBPF already is that you can actually convert some of the P4 code for packet processing into uBPF and then insert uBPF directly. Basically, you can convert P4 16-bit code into C code, which can then be converted into uBPF. So one of the use case that, like I mentioned before, vendors can now use uBPF with their custom code. One of the use case that has been discussed in the context was how can you extend K2SM models, service models? And again, I'm not a big, I'm not an expert in 5G specific aspects, but ORAN K2SM models today supports 3 models, right? Like the RAN control, the network interface, and the KPM model. So if you have to insert a custom K2SM model, then how do you insert it or inject it? If you want additional statistics, the only way is to actually make changes to the application code. With uBPF, you can actually get, and this would enable just the read access. With uBPF, you can say that, these are the parts that I can allow write access. These are the parts which are only read only. And that access is guaranteed through a verifier. When the BPF bytecode is injected, the verifier actually verifies whether there is only read access to certain memory space, and there is read-write access for other memory space. So all that is guaranteed, verified as part of the verifier. That's what gives it immense power. That is why most of the organizations, a lot of organizations are making use of or injecting eBPF bytecode in the kernel space for production environment to debug things and to get observability and to monitor things. That guarantee of not having the kernel to crash or the application to crash is what the guarantee is here. One more point I thought I would bring up is in the context of network microsegmentation. Now, traditionally, the network microsegmentation has been handled by leveraging eBPF network hook points that trace TCP control packets, and then creating a communication graph between two microservices or a set of microservices within the Kubernetes cluster. This can also be achieved using system call hook points. And essentially, KubeArmor is making use of system call hook points. The advantage with system call hook points is that the performance implications are much less, because you don't have to come in the way of regular network IO related processing. You don't have to inject a K-probe, or you don't have to enable a decision making process for every packet. So that's one advantage that eBPF brings to network microsegmentation from the traditional network microsegmentation mechanism. So KubeArmor already does this. Basically, what we do is using connect accept bind call, KubeArmor will send the alert telemetry and will create a Kubernetes network policy out of this, which can then be enforced by any of the existing CNIs, which supports Kubernetes network policies. And most of the engines, for most of the CNIs, already support network policies out of the box.
So Rahul,
Rahul?
Yeah.
Go ahead, sir.
So I was going to say some of the use cases in 5G may better utilize this kind of technology, which usually wasn't available in the past, except for some vendors doing funky stuff for CDN. Now that we're moving into session-based communication for UEs, so there will be, at least at the DU level in ORAN and CU level, there will be special tunnel created for user device, user plane traffic. Same thing can be said on the uBPF too, that when a session gets set up, the tunnel is created, and then tunnel has 2 known points. At that point, if your uBPF code allows use of traffic redirection, then you can isolate further system calls and have that traffic payload be transferred between 2 endpoints at the TCP stack layer. without every time packet comes in gets processed through the CPU with the full verification. So this was the kind of technology most CDN people use when they were streaming video, for example. After the session setup, they will continue to sort of CPU bypass type of scenario where you don't use the whole stack. You just use the TCP stack to forward the packets from one endpoint to another.
So Rahul, this is the piece where I can actually, this discovery engine is what allows you to actually see what's going on. And so it says you're generating your communication graph. So essentially what you're doing is you're using this to generate your LSM. You can use this and then generate your LSMs from the communication graph.
Correct. So this is the piece which actually discovers, and this has all the heuristics built, which says, a lot of times, you have file accesses are very wild, right? Like you have random files getting created, all of those, and then aggregating it at a folder level. All of those heuristics are built into this particular engine. But yeah, it can be made use of to not only discover Kubernetes network policy, it can take in telemetry from KubeArmor, it can take in telemetry from an CNI, container network interface like Cilium or Calico. It can take input from service mesh as well in the future, and then auto-generate service mesh policies here, which can then be enforced using Istio or Linkerd or anything. So the intention is to keep this engine generic and build policy recommendations for all of these workloads. Yeah.
So if you can't say, that's fine, but are you using various types of machine learning algorithms, techniques behind this, or is it more, just straightforward? I'm looking at this and I'm going to build a graph.
No, it's straightforward actually. Today we have certain heuristics built, but it's file aggregation, URL aggregation heuristics that we have built. But right now we are not using any machine learning algorithm. It's a very deterministic system today.
Okay, cool. Thank you, because this is a conversation I've been having with people. Because it's a lot of data, but you should be able to just use your standard graph algorithms to take data and build a graph. And because honestly, your firewall rules had better be deterministic, or you're going to have an outage.
Correct. So one of the things with zero trust is that if you're not able to figure out all the possible access points, all the possible execution points, if you end up not even figuring out one particular execution point, your whole application is going to go down.
Right.
Right. So it has much bigger applications. Of course, there are other ways to handle it. You put everything into default audit mode for a certain duration of time. Let the team look at, but all of that increases the time for which the workloads might not be in a secure mode for.
But this one would be basically, you can start off with all your nodes being, blocking essentially, and as you see traffic that's allowable, you turn the black to white on the edge.
That's what. That's essentially it. Cool. So just few points here about known issues with eBPF. Some of the major issues are that we have faced as a community, developing KubeArmor is not all the primitives are supported on all the host platforms, on all the platforms, all the distributions. This again is not such a major problem today, because most of the managed cloud providers have at least moved to newer kernels. Like most of the managed cloud providers today, it's for more than greater than 5.x kernel version. It's the upgrade velocity is mind blowing. Every 6 months they are upgrading the Linux kernel today.
And that includes Azure.
Yeah, that includes Azure. Azure Mariner has by default. It's based on Ubuntu, so it by default supports 5.x version. Yes. The other one other problem is that certain managed models like AWS Fargate and GKE Autopilot won't allow you to deploy daemon sets. And basically what it would mean is that you won't be able to deploy eBPF bytecode at all in those kind of environments. With AWS Fargate and GKE Autopilot, you don't have any control over the host, which means you won't be able to deploy anything, any eBPF bytecode at the host. So that's a problem. But again, these managed models are now considering enabling eBPF related primitives to be inserted at the host on whatever that workload is going to get deployed on. So this is currently under active discussion. I believe maybe in another 1 year's time, this might change as well. Issues with hooking up user space dynamic events. I have already talked about it. There are security issues. Apart from security issues, there are other issues, like you have to maintain the application binary interface. ABI. The ABI gets changed much more frequently in user space. So if you are using uprobes and hooking into SSL write, your SSL write, if you become overly dependent upon those kind of interfaces, then there is a chance that those interfaces might change. In the user space, the chances of changing are much higher. So the maintenance it requires a lot more maintenance effort than for the kernel space does. Packet parsing with uprobes have performance impact. And another thing is the possibility of eBPF event loss. There is every solution that I have seen will face eBPF event loss. So there has to be contingency plan in your whole architecture. If the event get lost, how do you deal with it? So that has to be taken into consideration. I guess that's these are all this. I mean, I have more slides, but I think I'm going to stop here. Any other question or any other points in the context?
Rahul, this has been very informative. Thank you so much for taking your time.
Thank you. Thank you so much.
Yeah.
Is it possible for you to share this slide deck? It's very informative.
I have shared the slide deck with Mudassar already. Yeah, sorry.
Okay. Yeah. Thank you.
Also, Rahul, could you share? Is it possible for you to share your contact information?
Yeah.
Or I guess Mudassar probably has it as well.
Yep.
Yeah, I have his information.
I'll get it from you, Mudassar, if I need it.
And
yeah, this has been really interesting.
And the team is also helping us in Super Blueprint. As you recall, the slicing and slicing related segmentation is a big thing. And right now we are working on a solution that will allow us to use eBPF to create secure network slices.
Yeah.
Okay. Thank you.
Thank you very much.
All right. Yeah. Thank you, Rahul. Very, very good presentation. And thank you, Mudassar, for allowing us inviting Rahul. So as we have just a few minutes left, so I'd like to cover just one thing. We have ongoing work with Amy and Jess for the two-factor authentication for OJSI. I think it will be important to check if this is enabled and works for you guys, right? And this is like a last step for us to share good news with the CPS team that they earned the gold badge, probably, right, Tony?
That's correct.
So what
when I checked
the next steps? Yeah. Mm-hmm.
Yeah, I checked it late last week, and it still had not been enabled for me for OJ. So I'll reach out again today to Jess and find out what the status is.
Yeah, it's actually anytime you're asked for your Linux Foundation credentials.
Okay, so I don't have this, for Linux Foundation credentials, yeah, LFID, right? LFID, right? When you enter and you want to log into the wiki and so on, right?
Yeah. So try clicking the log out on any of the LFI or no Linux Foundation web pages, like bringing up the wiki or whatnot, and then log in again and see if you have it.
Yesterday, I did not. It did not enforce it. It did not ask me for two-factor authentication. I had to relog in.
Yeah, me neither.
So
Okay, so work in progress. So we need to keep on checking with Jess, providing maybe some feedback that it still may not work. One more item, just last, sorry guys, is that we had some recent discussion on some new CVEs that were related to Carl. We had discussion at the PTL score. Initially, it looks like potentially as a low impact for ONAP. But yeah, I would be interested in your takeaways and feedback, and please check for those CVs. Maybe it would be interesting for you. And for the packages upgrades, Amy just submitted the Jira tickets, right, Amy? So
Yes.
we may move on with the projects for their upgrading journey for the Montreal release. Okay, I think we reached the top of the hour. So last but not least, next week I will be on the PTO, and Amy may have also some limited access availability on Tuesday. So are you okay if we cancel next week meeting? So we could have the week after meeting. I will be in business trip, but Amy could lead the meeting, so we could meet on the 24th.
That's fine. That's fine with me.
Okay.
Okay. So thank you very much, guys. So Mudassar, please upload the slides at the wiki here, and yeah, I will modify the agenda because we.
So here's a question before we drop off.
Yes, Tony, please.
They looked at the SBOMs for our code to see if we will be affected by the libcurl issue.
I have not. Good point. Yeah, we could do this. Do you volunteer in Tony to take a look and give us feedback?
I'm not sure how to look at those SBOMs.
Their list, I'll send you a URL.
Okay, so Mudassar, please share the URL. Maybe we could use the distribution list so everyone could take a look. Okay.
I'll do that.
Thank you very much.
By
All
the
right.
way,
Yeah.
quick note on container signing.
Yes.
It may require some work on LFIT part for JJB. I reached out to them when I was trying to assess which project to pilot with. So I think they first have to do the code, and I'll find out what's their timeline to add that code for container signing, and then we can pick a pilot.
All right. Thank you, Mudassar, for checking out and sharing with us today. All right. Thank you very much, guys. Thank you, Rahul, again for great presentation and sharing with us. And have a wonderful rest of today. We keep in touch. And next meeting we have in 2 weeks time frame. Thank you.
Thank you. Okay. Bye-bye.
Stop the recording. Bye-bye.